Quello che segue, secondo me, è il più straordinario seminario tecnico su TV proposto da un'azienda che produce TV e che vi sia mai capitato di osservare. Aggiungo che non ho avuto alcun problema a registrare e pubblicare tutto quello che vedrete, al contrario della quasi totalità di tutte le altre aziende leader del settore. Lo scorso 13 maggio 2026 ero a Varsavia per l'ormai consueto evento Experts Meet Experts, organizzato da Marek Macejevsky di TCL Europe in una versione tagliata su misura per l'EISA, l'Expert Image and Sound Association, il gruppo di riviste specializzate di cui avmagazine fa parte. Un evento che è una rarità in questo settore perché la maggior parte delle aziende ormai non dicono quasi più nulla, mentre preferiscono addirittura perfezionare la stessa strategia di marketing che seguono da anni, particolarmente arida di contenuti tecnici e che rende sempre più difficile capire il reale valore di un prodotto prima di poterci mettere le mani sopra. Al contrario, Marek Macejevsky si muove da sempre nella direzione opposta, mosso probabilmente da una cultura tecnica sulle tecnologie dei display decisamente superiore alla media. Marek si occupa anche dello sviluppo dei prodotti destinati al mercato europeo ed è l'anello di congiunzione tra ricerca e sviluppo, produzione, distribuzione e marketing, tutto condensato in una sola figura che manca praticamente in tutte le aziende concorrenti. Marek risponde anche a tutte le domande tecniche, anche le più difficili e sfrontate, ma attenzione perché non perdona quelle inutili o poco significative. Ed è soprattutto grazie a lui, alla sua competenza e autorevolezza, che le riviste specializzate hanno iniziato ad apprezzare e a poter anche verificare le caratteristiche di qualità e innovazione dei prodotti a marchio TCL. Continuate a seguirci perché in questi giorni, proprio in questa settimana, pubblicheremo altri contenuti sui TV TCL con tecnologia SQD-Mini LED soprattutto, compresa un'analisi preliminare con misure sui primi TV su cui io e Nicola siamo riusciti a mettere le mani. In più ci sarà anche un altro video, probabilmente la prossima settimana, con il reportage di tutte le demo tecniche che erano qui a Varsavia. Un reportage fondamentale per comprendere il livello di totale follia che permeava l'evento organizzato da Marek Macejevsky e dal suo team. Godetevi quindi l'integrale della sua presentazione della nuova gamma TCL che è super interessante non solo per le note tecniche sulle nuove serie, ma anche per tutti gli approfondimenti sulla tecnologia. Non sto scherzando. Attenzione però perché la densità di informazioni in quest'ora, poco più di video, è straordinariamente elevata, quindi assorbire così tante informazioni in così poco tempo per alcuni potrebbe essere davvero impegnativo. In bocca al lupo quindi, continuate a seguirci e passate parola.
Welcome to Meet Experts. So this is the event we organize on an annual basis to support technically our products. Experts Meet Experts, you see, is the way to share and be transparent with measurements. Also to let you know better our products and then also to share about technologies. So the plan for today is to cover these 8 major areas, not only TVs but also say something about soundbars and the monitors we have. But let's look on the market and what happened last year on European market. From the market perspective, you see that total Europe is around 31.5 million TVs. And but what is more important is that here 90% is smart TV, UHD stabilized on 67%, and then the fastest growing segment right now is Mini LED, and 55 and above continue to grow. On average in Europe is 41%, but there are countries like Germany, like Poland, like also Nordics, where 55 and above is already half of the market volume.
Do you have the lifestyle televisions there included? I mean, this
lifestyle, yeah, lifestyle is included, but lifestyle I think should be around 1% of the market.
1%.
Around 1% of the market. And what will
excuse me, you will send the PDFs after?
Yes, I will.
Okay.
And what we expect this year, so in general the scenario is plus minus 1%, so there is no change in terms of volume. However, we expect the average net selling price, so average retail price of TVs to grow. Then also look on the market or volume of OLED, which won't change. I will say later a few words why it is so. So then the Mini LED will continue to grow, and we see that also 55 and above will continue to grow. So this growing average price means that the growth by value we expect mostly in high-end TVs. This is why we have such a broad representation of this segment in our range. And then from the structure, market structure perspective, you can see that this year TV sets which are above 65 inch represent already 10% of market volume, and next year we expect that it will be already 11%. So here you have this upper 10% from 90% up to 100 market share, and you see that 98 inch and above last year was already about 100,000, and this year we expect it to be close to 200,000, and this segment will continue to grow. How Mini LED will develop the market, you can see on this yellow areas. So this is the total market, and you see that 26 we already expect Mini LED to overpass OLED in terms of volume. And this will continue to grow. Why OLED will not grow? Because of production process, which is extremely expensive, and there is no way to fix to address and then to quickly scale it. And then also OLED is mostly good for small screen sizes, but large screen sizes doesn't work. Most of the growth of Mini LED we expect in segment 750 euro and above. You see how it will evolve. From the market point of view and evolution of the market, you see that the market is stabilizing on this 1.5 million, and also the replacement cycle is stabilizing, so in some countries, which is over 9 years. But if you see on average screen size, so then over last 15 years from around 30 inch, it is right now reaching in some countries even 65 inch as average. So it means that there are a lot of big screen TVs which are sold. We talk about replacement cycle, so here you can see comparison between the market and number of households. So you see that there are markets like France, Germany, Poland, where people already replace TV set less often than 9 years. That's why we have for you today comparison of the TV set which is 10 years old. So first ASA TV set from 2017, and then from this year, so you will see the difference. But another point is that also habits are changing, because people don't spend 4 hours as it was in the past in front of TV, but less. Viewers younger than 45 years prefer streaming as the first choice. Only viewers above 65 prefer traditional TV. So then it's not anymore television, it's a total vision, because we have a lot of sources of the signal coming to the TV set. From TCL perspective and panel developments, I see that eco-friendly displays, so low power consumption, are key. Then we continue to develop inkjet printed OLED starting from IP screens. Then the next good and interesting point is our flexible screens for automotive industry, because there will be screens everywhere. And then 3D is back. You read somewhere the story that 3D comes back to the market and leaves the market, comes back and leaves the market. So right now 3D not for really TV, but for digital signage displays, usually in the airport when you walk at certain area you have 3D effect, but before and after it is 2D effect. So it is not as in the past, distorted before, distorted after, and only at sweet spot 3D. It is still 2D and become 3D. It's a new way of, let's say, getting attention of viewers. In TCL, we can cut every panel size. This is what we call vertical integration, and from two major factories, and a lot of other activities also for IT panels and inkjet printer panels. You see that any size, so right now 115 is here, 130 is maximum TV which can be cut, which means sooner or later we will hopefully see together, and you will see also 130 inch, but I worry that not in this hotel, because then what we can carry on over stairs maximum is 115 inch, because 50 years ago nobody planning this hotel expected this event here with such a big screens.
Next year you have to choose the bigger one.
Well, but then this is iconic, and you know, it's like a homie for years and for everyone. So whoever we say this hotel, everyone comes. So.
Munich was also high-end headquarters. Right now it's enough.
Then we talk about different technologies, and then how these technologies evolve. Today here you have comparison of four major technologies which are currently on the market. So emissive, there are two technologies like white OLED and QD OLED, and then transmissive, which is SQD and RGB, and also other technologies, some of them are future. You can easily see that OLED is generally expensive, has a lot of technological processes, very difficult to scale, and then is also limited by the yield. So if we want to cut larger panels, so the cost become enormous. The most easy to scale technology to deliver performance is Mini LED in two ways, and then module micro LED. It's just luxury technology, it's expensive, and we don't expect any TV sets which are in accessible prices or acceptable prices for consumers to be available. And then we see this IGP OLED as future, but with QDEF, quantum dot electrical field, because only this way we can achieve REC 2020. So let's look on performance, and as a first step, let's try to understand how consumers use TV sets and what are typical use cases. So out of the box, we must deliver the TV set which is in standard mode, because this is energy efficiency, label and certification. And most of the users stay in this mode or choose intelligent mode, so 95% of cases is this one. But if we narrow to what we are here interested in and what we will continue our discussion right now, which is movie or filmmaker, we talk about 1% of use cases. But only here we can talk about accuracy and measurements, because this is purely subjective story. So we already know that we continue about 1% of cases. Then from the signal perspective, you see that the signal which is mostly used by TVs is SDR and 1080p, because this comes from broadcast and from content. All comes from big data, because there is a lot of big data reported by TVs, so then we can aggregate it, and this is the way how we know how today end users use products. Going further, and then how these parameters are put together, you can see that we can split signal types to different sources. Then again, we take our most lovely source of the signal, which is Blu-ray, which we see that today nobody uses it. Of course, you use it, I use it. But this is how world evolves, and this is why consumers also shift to streaming. But if you look from the streaming perspective, you see this answer why 90% is SDR and 1080p, because most of the users just choose the lowest tier, and only fraction goes for this high-end tier. But anyway, we take all this together and create reasons to create TV sets. So we know already how, let's say, users use TVs, but also let's look on the content production, because there are many similarities between processing in TVs and content production. So we have acquisition, which are cameras. Cameras today can deliver 16 stops of dynamic range, which means it is much less than TV can do, but still there are a lot of things to develop, new sensors which will deliver wider dynamic range. Then there is post-production. Most of you think here about DaVinci Resolve as a software. Here is unlimited dynamic range and then non-destructive editing, so we don't expect a lot of changes here. Of course, there will be a lot of improvements coming from assisted AI or supervised AI, where users decide how to use it. Distribution, AV1 today, AV2 tomorrow. H.266 is somewhat set as a new codec, but I keep saying it is dead on arrival because there are a lot of patents around, and for streaming especially, the future is really cool. And the display, you might say, okay guys, we have such a beautiful product, such a great picture quality, but I will show you that still we have 15 or 20 years before us to deliver even better product. And on this slide you can see the comparison as we touch base already on DaVinci Resolve and then TV set. So what are the differences? So here you have, as you see, infinitive dynamic range because the calculation is done in flow. In TV set we are generally limited by the power, by the calculation capabilities. So we must achieve a similar result by doing a lot of engineering tweaks to deliver still great picture quality. When both worlds will meet, you see, we talk about 10, 5, 15 years in many areas. So I say that still we have a lot of reasons to meet again and continue to show you the new improvements in our products. So let's start from the high level and then to show you that all the products we have on the market we introduce follow the same signal processing path. Doesn't matter which brand it is always the same way, because technically there is no way to process signal any other way. Usually you meet people who only tell you how truly music is fantastic, but here I'm just open, transparent to tell you how it happens, and then step by step I will explain. And you see that with all these products, mostly the difference is at the end. I also show you that for RGB, you see that today dedicated processing chipset is required to make it happen. For SQD, it depends on number of dimming zones. So, as the first block is HDR processing, so in this block we have a lot of things to do to keep the picture quality on the level which you expect, and then to protect all the areas. So the signal is coming, we must analyze the signal to know everything about it, because in many cases it is not a signal coming with metadata. Then we must go to liner line and usually to use float blocks to recalculate it. Why? Because the signal further we can process only in gamma mode. And then why gamma? Because most of the algorithms which are used by the TV set are limited to gamma, like upscaling, like denoising, cannot work with PQ. And to work with PQ, we must do it in floating. So then we should put powerful GPU inside the TV set, but we cannot make it. So we can have only some blocks. But anyway, first step. We process HDR, we do tone mapping, and we continue. But as a reminder, what is HDR and how it compares to human vision, you can see here that we have scotopic night vision, so what PQ signal can cover. So very beginning means that you don't see colors, because even if the color is in the signal, your eye will never see it. It is night vision. Then we have step to trinit, which is twilight vision. In this case, you might see colors, but your accuracy of colors will not be good. And then day vision starts above trinits. And then we just split it to different levels, and that's why when we showed you last year some movies, and then these movies were extremely dark, you didn't see colors. Again, it's not because TV set is unable to display them, It is because your eye cannot catch them. From HDR perspective, we cover several formats. Then the new story, which is this year on the market, is Dolby Vision 2. Technically, there won't be any change. There will be only more metadata, so additional XML information, which will be added to the file. So the format will be still compatible with older TV sets, but the new TV sets will be able to use this additional information. And what this additional information is, you see here. So Dolby Vision 2 in the max version will come to TCL products by end of this year. We will start from C8L and above. What you will see working in the very beginning. So most these 5 functionalities will work, but this one is authentic motion where TV set is able to control, Dolby Vision is able to control frame rate conversion, and then switch it on, switch it off. We'll need support from content providers. And as you see here, this L18, 11, and so on are additional metadata layers, which will be supported by content providers. How long it will take to have native Dolby Vision 2 content? You see here. The source you see is just from Dolby website. It was published already in November last year. Then there is existing content, which TVs with Dolby Vision 2 Max will render better because there are revised or better algorithms to meet capabilities of new TVs. Then the next step, which is phase 1, is automatic conversion of actual current catalog to Dolby Vision 2. And the final step, which still will take some time, are tools with manual trims. So if you ever try to work with DaVinci with Dolby Vision license, you know that you can manually address all the trims, and this functionality is in fact phase 2. We talk about HDR, so then the next step is cleaning or artifacts removal. Here we address all the noise and all the compression artifacts. Then we go to upscaling. In upscaling, a lot can be done. Historically, it was big upscaling, so all the ringing issues you remember from the past because it was manual setting. Then the next step was machine learning and super resolution, where machine learning was able to recognize content type and drive the super resolution. Then there was this deep learning with edges refinements, and then with texture injection to get the best result. But this is upscaling, but many users in intelligent mode or standard mode, they want to have a super sharp picture. So that's why we have also detail control for this adjustment to avoid any changes here. And the final step is post-processing, where we must deal with the contrast and color changes and do a lot of compensations, because the whole chain is non-linear, and this non-linearity must be compensated. As intelligent mode is the important story in TVs, so here you have also explanation what it means in TV and what a neural processing unit does. Here we have both algorithms coming from chipset provider and also coming from TCL. So that's why it doesn't mean today that same chipset will provide exactly the same result for many TV sets. But one point for you to see is that in FilmMaker, everything is off. In movie mode, there are some options you can switch on, switch off. Generally, to follow this creative intent, even upscaling is off, super resolution is off, but of course you can switch it on and off and then decide if you want to use it. So the next step after processing is motion. In motion there are not a lot of changes, so there are slight updates related to cadence conversion, interpolation, and also ability to add interpolation to 120 gaming. So in a game mode we can have basic frame interpolation, but I think this is what you really want to know. So all the magic which happened inside the TV set when we deal with the picture and how we drive the panel and how we drive the backlight. So you see that when we enter this final stage, we again must go to liner light and we must deal with calibration and gamut mapping on the panel. And the difference which is linked to between old products doing full array local dimming and new products is changed here, because then we continue from this block in PQ in EOTF, because if we don't do it, then we cannot fully utilize this NIT and then correctly separate the video. The separation we call technically decomposition. Decomposition means that we separate the content layer and luminance layer. I think when you look on JPEG R, yes, format, where you have two JPEGs together, it's a similar concept, yes? That the separation, there is SDR layer which goes to the screen, and there is luminance layer, and of course there is an algorithm to compensate and to play. Why we have to compensate? Because here we must take all this LED and do compensation per zone because of spread of light, to be sure that the picture is uniform. 26-bit driving I will address on the next slides in details. And then final point is active matrix. With 20,000 zones, we must do it actively, because in passive matrix, driving power goes to LEDs with the control. With 20,000, you would see a lot of issues and uniformity problems, so power is separated, and you will see inside this X11L how, let's say, challenging design it is. So this module also manages APL and all this maximum brightness. So you see, let's say, this is HDR10 without any tone mapping, which comes to the TV set. And then we can move to back and forth, which is tone mapping, or we can move this way, the response curve, which is, in this case, light sensing. Then another answer to you, what is 26-bit and how it works, then it's not a fake story. So in simple words, it is current driving in 10-bit and also 16-bit PWM. Why we have to put it together? Because we can drive brightness in some steps and some details in PWM. So here you see in near black and then coming to different levels how, let's say, which driving works. Why we can do PWM in near black? Because your eye is not so sensitive for flickering, and then we can do it. But more we go to higher brightness, your eye become more sensitive. But we cannot fully drive with DC because of shift of color temperature of LED. So we have only limited amount of current we can drive. So here you have all the reasons where is DC limit, where is PWM limit, and then why we must put it together to achieve this effect you see. So it's not just, you know, a basic story. There is a lot of development behind to make it happen. Today we have two types of products on the market. SQD, where we use blue LEDs, RGB, where we use RGB LEDs. But you see that both share similar concept, which are transparent fillers. So to avoid, in this case, risk that the panel, if someone will touch with the finger, will touch the backlight. But these fillers in the past were non-transparent, and there were some shadows inside. So with this new concept, we resolve light distribution issues. X11L is 2 centimeters, which means we have only 5 millimeters space between screen and the backlight. You will see on this TV set, which is open there. And then how SQD looks in details, you can see here. So we have backlight, diffusion, then quantum dot enhancement field, Then light alignment, which is in this case to ensure that the light is not going to the sides, but is going directly to LCD screen, and the anti-reflection layer. And then...
Can you specify how much the anti-reflection film decrease the red?
You know, we can meet for another 1 hour. Because at least half of the slides I remove from this presentation about all these maths and efficiency. So if we will be able to organize another event this year, I will try to go deeper.
Okay.
Because we have full spectral analysis of each layer step by step, and then how it goes down, how it goes up, and so on. Okay? So it is also doable. RGB design is done in this way. You see that there is one layer missing, which is QDEF. There is no QDEF, yes, because we have the backlight, which is in colors. We have diffusion alignment, and everything goes to the screen. Then how we compare on the best value on our accessible level. So we have RM7L, which is our first RGB Mini LED, with C7L. What is the major difference? Here we have 1,300 RGB LEDs, but we have to divide it by 3 to count to the dimming zones, yes, if we look on the brightness. So we have only 448 dimming zones, but in this product we have 1,100 dimming zones. So this is the first difference you will see when you will try to compare this product side by side. And then from the contrast perception perspective, if we just separate the circles, so we put the zones together and how the zones are driven, so you see that this is also the difference visible between those two TV sets. So we keep saying that SQD is the one which is able to deliver much more, and then we have also side-by-side comparisons for you to show.
What's the difference between a white zone and a contrast zone?
But you must, you take the zone and you take 2 circles around and you split it. So I think it's 9 or something, and then this is how you perceive contrast, because the zone and the zone close to each, they are connected. If they are connected, so you will not, you cannot drive the contrast. You need more zones. So from the products in the past, if you had 100 zones, you remember that when you play this pattern to count dimming zones, it was just lighting up also zones around. So this is called circle algorithm, because then this is how it works and how, let's say, the power is distributed. So here is the comparison on, let's say, more high-end level, and here we compare C9L with RM9L and with X11L. So look on RGB, 11,000 versus 20,000, but this 11,000 is in terms of contrast, in terms of brightness zones, 4,000 zones, which is comparable to C8L. And then here, from the contrast perspective, that's why you perceive X11 as absolutely enormous performance. We have extremely high number of contrast zones, so what your eye is able to recognize, and if you come closer and closer to the TV, you still see very high contrast. But anyway, also look on the resolution of the backlight versus this one and versus this one, and you will be able also to compare it on this demo. So then, all what you want to know, and then the answer Photios to your question. This TV set, 115 inch, 16,000 RGB, 5,600. Okay? Yes. And this is the way how all these chipsets work, because the driving chipset has a number of zones, and then either you allocate them to RGB or to white. So that's why we still believe that the blue driving, white zones, it is much better approach to the TV set. And look also on the number of pixels per zone. In X11L, we talk about 400 pixels per zone, but then more we move to this direction, and then if you compare 98 inch with also flagship RGB, you have 6 times more. pixels, and then it goes this way. It continue to grow. How, let's say, we drive the brightness in TV set, you see here. So then we will be able to verify that X11 goes above 10,000 nit in boost mode. In this high standard mode, it goes up to 4,500 nit. And this is L size, means that in fact, if you convert it to window size, so the L, which is around 10, is in fact 1%, but later on I will show you all the Kalman measurements to be fully transparent with you. We also slightly revised the naming in 26 products, and then you see that whereas X11 and C8K is quite close in this APL curve, so in C7 we push a bit to this direction because of lower number of dimming zones and then to be less aggressive. So why we must start here from low number? Because here is the suppression of the halo around subtitles, but anyway we don't see really a lot of issues here. Then question we want to answer, how to make REC 2020. You know, you can do it in Excel in fact today. If you want really, you can do the modeling using Excel and some Python automation, and then it's the rocket science. I did it. So anyway, you just take a center of wavelengths, you take the width of this wavelength, and then you can calculate primaries, and you can come to the coverage, and then you can end up on this kind of slide. So going further and to compare C8L with C8K, you see where is the difference. How we made it. Okay, I'm fully transparent with you. This is, you see, 79% coverage of REC 2020 in C8K. Here is 91% coverage of REC 2020 in C8L. How to make it?
You have the new super button by playing with
Different center frequency and number on the green and red.
Okay. But if you only do this, so then if you only make the beams, so this is what we call FHHW, more narrow, okay, you gain 5%. How to gain another 5? And how to get really at the end to 2020 fully?
You need the precise frequency of the REC 2020 primaries. That's the problem. You don't have the right frequency for green and blue. Maybe
Okay.
for red.
Okay, so this is, let's say, the story that you can achieve 92, 93, yes?
And it's useless. I don't care about the 100%.
Yeah, but then you know, but the key point to make it happen is located here, which
Yes.
is crosstalk between blue and green.
Yes.
And to address this crosstalk, we need different color filter. So you see
Yes.
that color filter last year was standard color, and by this standard color, going above 80 something doesn't make sense because there is crosstalk. So to address this crosstalk, we need new color filter, which is new development, and that's why
and
you have TCL and other brands claiming REC 2020 because they all use the panel from the same factory. Because only one factory decided to invest into color filter because we must change chemically the color filter, and then you are told by everyone what the achievement.
what is this chemical composition of the filter?
Possible. In chemical, no, generally you have more narrow filter, color filter. So what you put just in front of the panel, you make it more narrow. But to gain this, to address this area and to gain this 5% of color gamut, we lose 20% of the transparency. So we must use more efficient LEDs on the for the TV set, so as to still keep the correct power consumption. So anyway, let's say further narrowing will help us to further grow, and then also further tweaking in terms of center will help us. So to go further,
Do they perform similarly in terms of power consumption?
what do you mean?
Well, if you narrow your filter, like you said, you throw away more light. So if you want the same light output, you need to
Yeah,
put
but
in
then
more.
LEDs continue to improve, as I say.
Okay.
So this is efficiency, because this you can compensate. So here
And
is
there's one question, the QD filter, the panel, is the same? Because you say super.
no, it cannot be the same.
Okay,
So then
what you added,
no, it's you make this particles smaller. So then we continue to decrease size of the particles, but with QD you are limited by all these European regulations, especially product must be below 100 ppm of cadmium to be able to sell it. So then you have a lot of constraints, but only TCL was able to overcome all these constraints and continue quantum dot story. That's why others decided to go for RGB. But RGB, you will see, I think, that if you put it for a long time in a very bright content, it should drift. Because green and red is not stable as a RGB source, so then this is something which is addressed with a lot of temperature sensors, and then it was the major reason why many companies, even, you know, if you recall, we met 5 or 6 years ago for the first Mini LED, and I said the future is RGB. But this is still the challenge, as only blue is very stable. So with the time and with the temperature, blue doesn't shift, but other colors shift. Okay?
Yes.
But this you should, I think, sooner or later discover. This is how these 3 products look like, spectral power, and then we did all for you to be transparent. We can go further and show you how it looks in Kalman. And then for all major products, what is the coverage, and then what is UTF. This product is not out of the box, it is after, say, very basic calibration, but in general basic, because we didn't try to be as flat as possible here, but then we are more or less okay, but to show you general performance, and then this data as reviewer guides you will get from us next week. Technically, we have right now a lot of panel types, and we have a lot of naming for these panels. Major difference is related to the type of the AR film, also the size of the bezel. As you see that in 98 we have bezel-less panel, as the picture comes to the bezel. In C7L we have bezel on the panel, but mostly also the difference is linked to this white color filter story with top products having them. Then there are a lot of reasons to buy a large screen TV set. It depends what you watch. If you really watch streaming, most of the streaming is the format 2.1, so 98 is just 95 inch. And if you really love Blu-ray, so 98 is 92 inch. And then what you can expect in many years from now is this, again, 130 inch screen, because what your eyes cover, what of your field of view can cover from 3 meters is 130 inch. Historically, only screens grow, but we don't change the space between us and the TV sets. Even if TV works in filmmaker mode, there are a lot of compensations inside, because we must overcome physical limits in luminance, color gamut limits, and also mostly deal with the optical stack, because here are a lot of issues to walk around. And then if someone wants to do the reconstruction, so optionally AI can be used. From the picture modes we have in TV sets, today these are these modes. This year we merged Filmmaker together with Dolby Vision, so if Dolby Vision content comes, so it's not anymore Dolby Vision Dark, but this is Filmmaker. And then Dolby Vision 2 will change IQ and other modes, but then when we release Dolby Vision 2, so then I will make update of this slide to show you more details about it. Calibration is just standard option today. There are a lot of tools on the market. Kalman, you know, stability of Kalman, but anyway, can be used with how to cal, and after 1 hour, some calibration effects can be achieved. Color space, okay, it's extremely complex and very professional. There are more and more, I see, tools coming to the market because they want to overcome limitations of this tool. So you should expect sooner or later new entrants to the market. And then this is mostly also for trade, as they want to offer this to consumers. Another interesting story for you is the evolution of chipsets and what happened in this TV development story. You can see here. So here are 10 years, okay? Then you remember, I think we had last year X1 TV set, 65 curved. It was based on this chipset. And in fact, this chipset was developed for SDR TVs. HDR was just added as a workaround to this TV set. So usually the cost is paid in dark areas because dark is causing the banding. As more bits we try to stretch, so then more details in darks we lose. Then there was 5 years, and then sort of improvement in terms of internal accuracy, but still accuracy was not very sufficient. And then arrival of 23 and this year finally address a lot of accuracy issues, and then issues related to banding or especially in dark areas.
The same pentonic can it be used in RGB and
But as I said,
more
the
communication.
only difference is the full array local dimming driver.
But more elements.
You were listening a lot of marketing stories from one company, and you start to believe too much. Right now you talk to engineers, but you don't talk to small stockers. So then, you know, they are just telling you what absolutely incredible it is and how many tweaks they did.
Okay.
Okay,
Same processor.
okay.
Thank you.
Just, you know, you should continue after the dinner this question.
How much bigger?
I just thought it because, you know, he trusts everything, so then, you know. Okay. Let's look on audio. And then on audio, we continue to the cooperation with Bang & Olufsen because this is a good outcome with fixing of the sound and having sort of European feel of the sound. Then from codecs point of view, finally fully DTS:X for streaming works because last year we still had the issue with DTS:X in Disney. This year it is fixed and also updated in other products. And then Flex Connect full integration. You can see that this is right now part of Dolby MS12 profile. It's called W to support full compatibility and integration with TV set. Then we also continue connection over HDMI where TV speakers and soundbar speakers can work together, and then ability for end users to choose different sound outputs. So experience, we focus on Google TV. Google TV has 3 major profiles, and then it is like this, in full in countries, in major countries. In some other countries it is in light version, and in Central Europe it is limited and without this content recommendations. But another funny story is that if you have your account in Google TV and you will spend more than 1 week in different country, so then it takes 1 month for the TV set to recognize that you return to your home country, and you still have the home screen from the country where you spent more than 1 week. So according to Google, you can only spend 1 week of holidays. If you are longer, so then it means it is permanent. But In Google TV, we have also a lot of updates. So right now we started to release Android 14 update. So all TVs starting, which we introduced in 24, will get Android 14, starting from higher end products and then going to lower end products. Then Google Photos is quite interesting screensaver, because in ambient mode you can use the TV set as your picture frame. And Gemini comes to TVs. This is according to Google. We have already first version for demonstration, but Google will decide country by country how they will release it. From the local content sharing, there are no changes. Everything is supported from all ecosystems. From control perspective, we have one addition, which is Control 4. So there is this functionality already integrated, and as external device control, and then for smart home, integrated smart homes, TV is fully controllable over IP. Some tweaks in UI, and then some updates in the game mode, game bar, also in the way how Flex Connect is set up. As I said, super resolution can be switch on, switch off, so if user wants to see with and without, it can be done. Automatic HDR conversion also can be done. And especially for Italy, DVB-I is already part of the working solution. Here you see that the installation of DVB-I is done via standard tuner, so for user it is totally transparent, and then it is just like another antenna. Gaming has only one update versus last year product. So this is this Game Pass, which will come end of this year, also starting from C8L. And as we always talk, input lag is always linked to the place where you measure this input lag, because the best can be is here. Average is here, but if you want to say that the product is bad, you measure in the bottom right and say, okay, very long. So then focus again when you will talk to your marketing colleagues, tell that this is the bad product because this is very long input lag. Design is must last long, because TV set usually will spend 10 years at home. But from this design perspective, you will see that even 10-year-old TV set we have to show you from our first ASA experience still fits in this concept. So metal central stand, and then as we talk about X11L 2 cm thickness, which is very thin, and then all TVs with cable management. But the area which is also important here is the sustainability. So we continue our efforts to provide lower and lower power consumption. Of course, it can be done at the cost of the brightness, and we can make artificially very dark TV set. But we still believe that the good brightness and then Class D in most of the products this year, and step by step this effort will continue. There are tons of regulations in Europe. Today, to sell product in Europe, we must provide around 300 of documents to the trade to let them list. If we don't, they cannot list, they cannot sell. Then there are also a lot of restrictions for materials. We must all meet, and then we must continue to show that we decarbonize our products with efficiency, energy efficiency, and then as small packaging as possible. So this is what we do in the TV range between 25 and 26. You see that we continue to expand product range. Most of Mini LED products from last year go to SQD. We have 2 RGB lines because there is a market, some companies will support it, so then we also provide this choice to consumers. Then we even do products with 120, 144 screens. We add the full array local dimming. And this is the master range for UHD products. You see how broad this range is. Then we have, especially for our customers, country by country, they expect the exclusive product. So this is what we call line range, because this is like C89, C79. Then we have also QLED range. Some other customers, especially Nordics, prefer this naming and ask for specific exclusive functionalities. So you can find these products. And there is also online range with Q and V. So here is the Fire TV, for example, as the operating system for entry product. But there is also iFalcon you can find on the market, which is fully supported by TCL. And as
the lowest model for Super Quantum Dots, which line?
C7L.
7L, not the, because here we call Q7D Pro.
Q7D Pro, which is MS, which is similar to MS QLED, yes. So yes, you can. But in the master range is this one. Q7D Pro is has lower number of dimming zones, and then it is for online range.
But it's a Super Quantum Dot.
It is, yes. It is similar to C7L, only with lower number of zones. So then the front is the same, then the backlight is different. As you asked about this next vision range, so then A300 is step by step replaced by A400. We have 3 iterations of this product range. So matte screen with Mini LED backlight, then anti-reflection glossy screen with Mini LED backlight, and then dimming, global dimming with standard screen. Only this come with the frame. You can see the range here. And then a quick look on X11 comparison between this year and previous products. So color gamut, driving, more zones, brighter, panel with wider viewing angle. Then how challenging is the design of the product you will see here, and what components we have. RM9L, which is RGB. Comparison here, we compare it with C9K because it was more or less the level of the product. So this one was QD, this one is RGB. So the same improvement in terms of gamut, also brightness, and then dimming zones, because even if you divide here by 3, you still have a higher number than in the previous year product. Technically, this RGB is also a challenging design. It looks this way. Then we come to C8L, which was always our focus of the product in terms of performance. So 8K versus 8L, we have also comparison here. You see color gamut, driving, more dimming zones, brighter and improved panel. And also here and in previous products, Dolby Vision 2 Max will come as a software update. Then C7L, which we call, which some of you also said, it is one of the best offers from TCL, as it blends key technologies and functionalities at very accessible price. You see it here, slight improvement in dimming zones, similar brightness, wider color gamut, and then you have all these products here we show. So before we finish, quick look on the Soundbars and what we do. In Soundbars, we focus on TV integration, but if you connect Soundbar, you see all the Soundbar settings on the TV screen. You will be able also to test it, as we will send you both TVs and Soundbars. Then, as DTSX is more and more supported by streaming providers, we provide this functionality. And then integration with TV sets. Flex Connect we did as a teasing last year, and mostly to show that the product is interesting. So after publications, final decision was taken to start selling. This year we have more colors, and we have also subwoofer. Subwoofer can be used also along with the TV set. Setup is very easy. All the processing is done in the TV set. We have demo in an apartment in this hotel with 4Z100 subwoofer and X11, and also you will be able to hear it in Atmos and DTSX. So you will see how big is the difference, but it mostly comes from different type of the mix, because DTSX is derived from the cinema and Atmos is done for home cinema. From the range perspective, this is current range. New products are mostly this Z100, A65K, and here the K range, because there will be next wave of soundbar introductions and phase out in September, October. So for the time being, I can show the current situation.
Marek, one question. Do you have market figures for the sound bars as you have for the degrees?
So honestly, it should be around 14%. Market by market, it is different. European average should be 14. So if you have 31.5 million of TV sets sold, so what? 3.55 million should be market for soundbars total. Okay, in US it is 30 something, but this 14% means that 35% of 55 and above are sold with soundbars, because below 55 in general soundbar doesn't work well, because TV set logically you should have the logic of half of the cost of the TV set. Should be the soundbar, but we believe that Flex Connect is much better solution, because it is wireless. It's ready for your wife, because wife hate cables, so then there are no cables. Everything is, can be set up in every place, because soundbar speakers, real speakers, it's always a problem, yes? Don't put it here, it cannot be there, okay? So then Flex Connect, you put everywhere, everyone is happy. So Flex Connect then working in all the combinations 1, 2, 3, 4 and together with subwoofer. A65K super slim soundbar, we have it here done together with DNO. You see only 5 millimeters. So then we know this is also the segment which become more and more important. And then the last point about monitors. Why monitors? Because the size of the segment in general is similar to TV market. There is a lot of interest in gaming monitors, because not everyone wants to use TV in the living room to play. TCL has advantage in the panel production and also in Mini LED products. But as market is not only made by Mini LED products, we have also one OLED monitor this year. So from flagship perspective, you see there's 57-inch super wide, this 27-inch, which we call dual mode, as it works in different resolutions and can go up to 320 Hz in Full HD. And OLED version. This is just the roadmap. You see how broad this roadmap of products is, going from the OLED through different Mini LED screen ratios, and then going down to global dimming. So this is all what you get from us as usual. After the event, you will get pictures, you will get all the links, reviewer guides, and then photos from this event. And now, step by step, we can go to demos. We have a lot of demos, not only in this room, but also in other rooms, and also for your ability to measure. So that's all from my side. And then we will meet again in this room tomorrow for the webinar. And we will connect to Australia.
One question. Some companies, they have AIDS. RGB light now, and they say RGB. What do you think?
But again, you trust people.
No, not trusting. They claim that they are.
But you can claim anything. It's today. The idea from our side was to make this Edge Mini LED TV set from one company, as you say, or let's say as many companies. Honestly, after CES and one company who just used TCL TV set with desaturated picture, showing how bad is TCL, how good is this company, I told no way, we don't do side-by-side comparisons because then everyone can say, you tweak and so on, this is different signal. So if we ever do it, we will have to do it in a way that each time you will come and you will confirm that you check and there is no bullshit, everything works as we said, and then you as a Photios, you check by yourself and then you compare. So then, let's see, maybe you will create this kind of form of comparison and then we will put the TCL products and competitor products. The only question is why I should pay for these products and then why I should buy them. So then it's another internal discussion if I should support another company in buying their product to show how bad they are.